Have you ever wondered how our closest celestial neighbor, the Moon, came into existence? Our journey begins around 4.5 billion years ago, in the early days of our solar system. Back then, Earth had a close encounter of the celestial kind. Enter Theia, a Mars-sized body whirling through space. This wandering celestial object, named after the Greek Titaness and mother of the moon goddess Selene, found itself on a collision course with Earth. The impact was colossal. Theia was completely destroyed, and Earth was left forever changed. But what happened next is the real magic. Debris from this massive collision was sent hurtling into space, forming a ring around our planet. Over time, this debris gradually coalesced, coming together to form our moon. Yes, that's right. The very moon that you gaze upon in the night sky that has inspired countless poets and dreamers is the result of a cosmic collision that happened billions of years ago. Now that we know about the moon's birth, let's delve into its composition and structure. The moon, much like Earth, is composed of a variety of elements that are essential to its structure. Oxygen is the most abundant element, making up a little over 40% of the moon's mass. Silicon follows closely, while other elements such as iron, calcium, and aluminium are also present, but in smaller amounts. The moon's anatomy is divided into three main layers: the crust, mantle, and core. The crust is the outermost layer, a rocky shell that's approximately 30 to 40 miles thick. Beneath the crust lies the mantle, a region composed of minerals like olivine and pyroxene, stretching about 1,000 miles deep. And at the heart of the moon, we find a small, partly molten core, predominantly made of iron, with traces of sulfur and nickel. While Earth's core is a dynamic, swirling mass of molten iron, driving our planet's magnetic field, the moon's core is quiet. It's significantly smaller, and it doesn't generate a magnetic field of its own. This lack of tectonic activity contributes to the moon's cratered and scarred surface, a testament to billions of years of meteorite impacts. Despite its lack of tectonic activity and a significantly smaller core than Earth's, our moon holds fascinating geological complexities. Its unique composition and structure continue to captivate scientists and space enthusiasts alike, revealing new insights into our universe's vast expanse. Ever wondered how our lives on Earth are intertwined with the moon's existence? Let's take a closer look at this celestial relationship. The moon, our nearest cosmic neighbor, is roughly 238,855 miles away from Earth. That's about 10 times the circumference of our planet. In the grand scheme of our solar system, the moon holds the position of Earth's only natural satellite. Its gravitational pull is a major player in causing the ebb and flow of Earth's tides. Imagine the ocean's waves rolling in and out, all under the moon's silent command. The moon doesn't just sit idly by though, it's always on the move, completing a full orbit around Earth approximately every 27 days. This lunar dance is what gives us the various phases of the moon we see throughout the month. Without the moon, our world could have been a very different place. From tides to nights, our moon's silent influence is profound and ever-present. Imagine spending a day on the moon. How different would it be from a day on Earth? Well, for starters, a day on the moon isn't 24 hours. It's about 29.5 Earth days. That's right, almost a month. This is because the moon rotates on its axis at a much slower speed than our home planet. As the moon orbits around the Earth, it also rotates on its axis. However, the moon takes the same time to rotate once on its axis as it does to orbit the Earth once. This is known as synchronous rotation, and it's why we always see the same face of the moon from Earth. Despite the slow rotation, the moon does orbit the sun just like Earth. But remember, a lunar day is not divided into daylight and darkness like on Earth. Instead, the moon experiences about 2 weeks of sunlight followed by 2 weeks of darkness. So, if you were on the moon, you'd have to wait almost a month for the sun to rise and set. The moon has been a silent spectator of Earth's evolution for billions of years. But what about its own state today? It's a world where the air is absent and the weather harsh. Daytime temperatures can soar to the boiling point of water while nightfall brings a deep freeze. Yet, intriguingly, within its polar craters, water ice might be lurking. The moon, with its serene beauty and harsh environment, continues to captivate us, doesn't it?